So yesterday we started section 4.1. Okay, we talked about all of these definitions. Pull them up. Okay, we're going to use these today, okay, to solve right triangles. All right, any questions on those 6 definitions? So each trig function, okay, people say, well, what does sine really mean? Okay, sine means it's a fraction. It's a ratio. It's a ratio of 2 sides in a triangle. Specifically, you take the opposite side and you divide by the hypotenuse. That's what sine means. It's a number. That's all. Okay? You find the sine of an angle, you just get a number that represents a fraction. Okay, so we'll be using those in a little bit. Okay, so first thing I want to take a look at is the idea of complementary angles. Okay, what does it mean if 2 angles are complementary? Yeah, David?
Together they reach 90 degrees.
And by reach, what do you mean by reach?
I mean they add up together.
Okay. Good. So complementary angles, they add up to 90 degrees. Okay, so I'm going to say this fact, and I want to know why this is true. I'll draw a picture. The 2 acute angles, this one and this one, are always complementary in a right triangle. Why is that true? The 2 acute angles in a right triangle are always complementary. They always add up to 90. Why? Emily?
Because the triangle is 180 degrees and one right angle is 90, so the other 2 have to equal 90.
Right. If a triangle adds up to 180 degrees, and you've already used up 90 for the right angle, well, the other 2 also have to add up to 90, or it wouldn't be a triangle. Okay, so any question on the idea of complementary angles? All right, so just take that idea, kind of set it aside for a second. We're gonna use that with this idea. Okay, cofunctions. Okay, cofunctions are basically a different way that we can pair trig functions together. Okay, we've already learned one way to pair them. We paired sine with cosecant. We paired cosine with secant. And we paired tangent with cotangent. What was the connection here? If you have one to get the other. You flip it. Yeah, it's the reciprocal. If you have the one on the left, you flip it to get the one on the right. Okay? This pairing is called reciprocal identities. Okay? We're going to look at a different pairing. Okay? Called cofunctions. If you read all 6 of these trig functions, 3 of them have the word co in front of them. Okay? And to find the cofunction, if you're given a trig function, basically just put the word co in front of it. So we have the trig function sine. What do you think the cofunction of sine is? Cosine. So you have sine, put the word co in front of it, cosine. These are called cofunctions. It's a pair. Sine and cosine are one pair of cofunctions. Okay. How about secant? Secant, cosecant. This is a second pair of cofunctions. And how about tangent? Cotangent. This pairing happens to be the same as the one we learned before, the flipping one. So, any questions on these 3 pairs? Okay, these are called cofunctions. Okay, let's get a diagram. So here's a right triangle. And I've labeled all the sides A, B, C. And now we need a way to label the angles. Okay, sometimes books use capital letters and lowercase letters to label angles. I don't like to use capital letters for angles and lowercase letters for sides. I think that gets confusing. Because then if you ask me a question like, well, what's B? So now do you mean capital B or lowercase b? It leads to confusion. So to kind of avoid that, what we're going to do is use what you've always used for sides, A, B, and C, okay, English letters. And then for angles, we'll use Greek letters. Okay, so all angles will be Greek letters. That's how we'll represent it. A is the first letter in our alphabet. And this letter is the first letter in the Greek alphabet. Anybody know what letter that is? Looks like a fish. Alpha, yeah. Okay, so when you draw a right triangle diagram, wherever you put A, you've got to put alpha across from it. A and alpha have to be across. Okay, B, it's the second letter in our alphabet. This is the second letter in the Greek alphabet. Anybody know what letter that is? Beta. Wherever you put B, put beta across from it.
How is that actually written?
Beta, it's like a long, like one side looks a little longer. And then the top part kind of looks like a B. Alpha looks like that, beta looks like that. And then always keep C as the hypotenuse. Okay, let's look at some trig functions here. Let's find the sine of alpha. Okay, it's not going to be numeric. It's going to be letters. But I want the sine of alpha. And sine is opposite over hypotenuse. Okay, so Tatiana, what side is opposite alpha? A. And what's my hypotenuse? C. Good. That's the sine of alpha. It's A over C in this triangle. Okay, let's find, we're done with that part. Okay, let's find something else. Let's find the cosine of beta. So cosine, that's adjacent over hypotenuse. Okay, Jalen, what side is adjacent? A. Good. And what's the hypotenuse? Still C. What do you notice about the sine of alpha and the cosine of beta? Same thing. Okay, they come out to exactly the same thing. Okay, maybe just a coincidence. Let's see. Let's find tangent. Okay, let's do alpha. Right, so tangent is opposite over adjacent. Joe, what side is opposite alpha? Yeah. A. Good. And what side is adjacent to alpha?
B.
B. Okay, that's it. We're done with that part. Okay, tangent of alpha. Now let's find the cotangent of the other angle, beta. Okay, cotangent. If we're not sure, let's look it up. It's adjacent over opposite. Adjacent over opposite. Anybody see what the cotangent's going to be? It's the same thing. Adjacent is A. What's opposite? B. All right, so that's more than a coincidence then. Okay. Anybody see the connection between sine and cosine? What are those called? They're cofunctions. Good. And what about alpha and beta? They're angles, but there's a special relationship between them. They're complementary. So we had cofunctions, angles that are complementary. Came out the same. Let's check the next one. Tangent and cotangent. Are those cofunctions? Yeah. Alpha and beta, those are complementary. Cofunctions, angles that are complementary. Came out the same again. Okay, so that leads us to the complementary angle theorem. Okay, it basically says what I just showed you. If you have cofunctions, and you have angles that are complementary, they come out the same. Okay, they are equal. So let's try some with numbers. Right, so on the left, I've listed 3 trig functions, and I've plugged 3 different angles into each one of them. Okay, on the right, I want to find something that's equivalent to it using this idea. Cofunctions and complementary. Okay, so I'm going to start with the first one. Sine of 30. Okay, Brianna, what's the cofunction for sine? Cosine. And what's the complement of 30? 60. So she picked the cofunction for sine, then she picked the complement of 30. Complement means what adds up to 90. Right, so if you type that in on your calculator, you get exactly the same thing. The sine of 30 and the cosine of 60 are equal. Okay, I'll show you where you'd use that in a second. Let's try another one. Tangent 15. Anyone think they could tell me the cofunction and the complement? Give me both. Yeah, cotangent 75. Good. Okay, so you're looking in that list, find the cofunction for tangent, and then find a number that adds up to 90 with the one you were given. That makes it complementary. Okay, and how about somebody else? The last one, we have secant 40. What would that be the same as? Yep.
Would it be cosecant 50?
Cosecant 50. Yep. Good. Okay, and here's where you would use something like that. Okay, I want to simplify. Okay, I want to figure out what that is. Okay, and for this part, I'm not going to use a calculator. Let's just look at what we've got. Sine, cosine. Those are cofunctions. 15, 75. What do those two numbers add up to? 90, so they're complementary. So we've got cofunctions of complementary angles. Now, I have no idea what the top is. The sine of 15, honestly, I don't know what the sine of 15 is. But I don't know the cosine of 75 either. But what do we know about the top and the bottom? They equal each other. That's the whole key. Everyone see why these are the same thing? Cofunctions, angles that are complementary. You're dividing two things that are the same. Even if you don't know what they are. Somebody says to you, I'm dividing two things that are the same. What do I get? You can just say 1. The only difference is this has a negative in front. So instead of 1, we get -1. That's it. So this is just a trick for simplifying expressions in special cases. If you change this 15 to a 16, well, now you can't do it. Now you need a calculator. Okay, so it's that one. And how about that one? If you think you know it, don't say it yet. Just take a look at it. Tangent 12, and then cotangent 78. And my hint is you're never going to know what the tangent of 12 is, and you don't need to. And you're never going to know the cotangent of 78. You don't need to know that either to figure this out. Correct?
0.
0. Why is it 0? Because what?
They're equal.
They're equal. Yeah, you're subtracting two things that are the same. I don't care what two numbers that you subtract. If you subtract two things that are the same, you always get 0. You don't have to know what they are. Okay, so this trick works for division, works for subtraction. Would it work for addition? If you add two numbers that are the same, do you always get the same thing? No, you get the number doubled. 5 plus 5 is not the same as 6 plus 6. So this trick wouldn't help you if I made it an addition problem. How about multiplication? If you multiply two things that are the same, do you get the same thing? No. 10 times 10 is different than 9 times 9. Okay? So you can't use this with addition or multiplication, but you can with division and subtraction. Any questions on that part? All right, so last part. Okay, for the rest of the class, we're going to focus on solving a right triangle. Anybody think they know what that means? To solve a triangle. Like if I said to you solve an equation, everyone would think, oh, that means find x, okay, or find what the variable is. Well, how about if I wrote to solve a triangle? What do you think you have to find? Just name one thing you have to find. The what?
The degrees.
What's that? I'm not sure what you mean.
All degrees means a triangle.
And what are those things that are degrees?
All the measurements.
The angles. Okay, that's one thing you need to find. All the angles. What else do you think you need to find? Yeah. The length of all the sides. Yeah. So to solve a triangle means to find the lengths of all the sides and the measure of every angle. Now, we're going to be solving right triangles. So what does that automatically tell you? There's always going to be a 90-degree angle. Okay? Every problem that you do is going to have a 90-degree angle in it. So there's one thing you don't need to find. Okay? One angle is 90. That leaves two other angles you got to find, and all three sides. Now, when I ask you to solve a triangle, I can't just say solve the triangle. I have to give you a little bit of information. Okay? And there's two cases of information I could give you. Does anybody know what do I have to give you besides the right angle? You always have that. Okay, I could give you a side, and I could give you something else with it. Yep, I could do that. So I could give you a side and an angle. Or anybody know what else could I give you? Or I give you two sides. Yep. So in addition to the 90, I'm either going to give you a side and an angle, or two sides. Okay, so we'll try maybe one or two of this first case, and then at least maybe one of the second case. Okay, any questions though about kind of the goal of what we're trying to do? We're trying to find out how long the sides are, how big the angles are. Two things to keep in mind. What's a fact that we know about all the angles in a triangle? They all add up to 180, okay, so we can keep that in mind. And what's another fact that we know about the sides in a triangle? Right, the Pythagorean Theorem. Okay, so keep that in mind too. And now we're finally going to use these definitions. Okay, my suggestion for people who have trouble visualizing, especially because we're going to start using opposite, adjacent, and hypotenuse, if you're not good at visualizing something in your head, you're going to want to make a diagram. Okay? A table is good to write your final answer and organize. Like if you're trying to show me what's your answer on the test, you can make a table to show the data. But I would make a sketch to visualize everything. Okay, so let's try solving a triangle. Okay, so this is an example of the first case. They gave you one side, and they gave you one angle. What I'm going to do for my table is I'm going to list A, B, and C, okay, going down one side, and then alpha, beta, and then the 90 going down the other side. If you have a better way to organize your information, that's fine, but I found the table seems to be simple and it works. So that's what we usually do. Okay, I filled in the table what was given. I put boxes around everything I need to find. Okay, you can find A, C, or beta. You can do this in any order you want. It doesn't matter. I would find beta first because I think it's the fastest thing to find. Anybody think they could tell me what beta is? Okay, how do we know, someone else tell me, how do we know it's 50? Yeah, it has to add up to 90. The right angle is 90. We just said the other two angles are complementary. So beta is 50. Okay, so now let me make a sketch. I don't really need a sketch to do beta. Okay, I know all the angles add up to 180. There's not much to visualize there. I'm going to put B on the bottom, which means beta. You know what? In fact, since we weren't given that, I won't even put it in the picture. Just going to put in the picture what I was given. A, I don't know. Not yet, anyway. But I was given 40 degrees. Okay? And I wasn't given C either. All right, so now we have a choice. We either can find A or we can find C. Okay? It doesn't matter which one we do first. Let's do A. Okay, so I'm going to find A. And I have to use two other pieces of information. Right now, I have three. I've got the 2, the 40, and the 50. Out of the 2, the 40, and the 50, what do you think the two best pieces of information to use there are? The 40 and the 2. Why the 40 and the 2? They were given. What's wrong with using the 50? Right. We could. I mean, we can tell we didn't make a mistake. But what if it was a little more complicated and you did make a mistake? If you use something that's wrong to find other things, those things are automatically wrong too. Okay? So the way we're going to do right triangle trig, you could make a mistake on one part, but still get everything else right. Okay? Just because you get one part wrong doesn't mean you get the whole problem wrong. The way we're going to do it. Right? So I circled the two pieces of information we were given, and I circled the thing we want to find. Okay, so now our next part. You have to choose between three trig functions. Right? Either sine, cosine, or tangent. Those are your only three choices. And to figure out which one you pick, we're going to look at the two sides we're working with and figure out their names. Are they opposite, adjacent, or hypotenuse? Okay. Start with the A. Relative to the 40-degree angle, what's the name of side A? Opposite. Okay, so we're looking for a trig function that has opposite. And what about the side that's 2? Adjacent. So which trig function has opposite and adjacent? Tangent. Good. So it's tangent of our angle, 40 degrees, equals, tangent is opposite over adjacent. Opposite over adjacent. A over G. Now the trig part's done. Now it's the algebra part. Get the variable by itself. Okay, how would you get A by itself here? Multiply each side by 2. And no, you cannot just double 40. That doesn't work that way. You're just going to take, and I'm going to type that in exactly like that on my calculator. 2 tangent 40. 2 tangent 40. Make sure you're in degrees. Every problem in this section is degrees. Okay, so A is about 1.678. Okay, I'm choosing just to round to 3 decimals. 1.678. Okay, so that's A. Now that I have A and B, I know 2 out of 3 sides in a right triangle. What could you do? You could do the Pythagorean Theorem, but why do you think, I think, that's not a good idea? Okay, yeah, 2 reasons. One, this is rounded. So it's no longer an exact answer. And if you use something that's rounded to find something else, now that's rounded even worse.
And you want
And what's another reason?
to use the given information.
Okay, we do want to use the given information because let's say this was even wrong. Let's say the answer is supposed to be 5.63. Well, now we're using the wrong answer. Now C is automatically wrong. Okay? So when you do right triangle trig, you never use something you calculate to find something else. You always go back to the given. Okay, always. All right. So now I want to find C, and I'm going to go back to the two pieces of information that were given. 2 and the 40. So now I'm working with everything I just circled in green. I got to figure out my trig function. It's not going to be tangent. I already used that one. So my choices are either sine or cosine. Okay, side, that's 2, Alec. What's the name of that?
Adjacent.
That's adjacent. And how about side C?
Hypotenuse.
Hypotenuse. So we're looking for a trig function that's got adjacent and hypotenuse. And cosine. So we're going to do the cosine. Fill in your angle. Equals adjacent over hypotenuse. 2 divided by C. Now this previous one was 1 step to solve. This is actually 2 steps. Okay. First thing I want to do is get rid of my denominator of C. So what could I multiply both sides by to do that? Just C. That'll cancel. Now I have C cosine 40 equals 2. That's C times the cosine of 40. And what's my last step to get C by itself? Yeah, divide by the cosine of 40. Okay, the cosine of 40 is just a number. It's a decimal. I don't know what it is. But whatever it is, just divide by it. Cosine 40 and cosine 40. Okay, I'm never going to know what the cosine of 40 is. I don't need to. I'm just going to type all this in just like that. I don't want to round cosine 40 off. It'll mess up my answer. So type in 2 divided by cosine 40. Okay, so you get 2.611. 2.611. Now what you could do, if you have extra time on the test, try doing a squared plus b squared and see if you get c squared. If you do, that's a good check to show that you did the problem right. If you don't have extra time to do that, don't bother double checking it. But why might it come out a little off? Because we rounded. Okay, so you might get you might be 1 decimal off or something like that. Okay, but that's the idea of how you solve a right triangle. Hey, any question on that? Okay, so I'll give you guys a choice. We either can try another one of this type, or we can go on to the next type. Everyone okay only seeing one of this type? Okay? Okay. This is another one. This is the same type as the last one. So the way I would do it if I was going to do it, find alpha first, draw my diagram, then find B, then find C. Always go back to what you were given. You're going to use A and beta to find everything. Okay, this type is a little different. Kind of already gave it away, but what's different about this type? Yeah. It gives you 2 sides, so you can't get an angle right away, quickly. Okay, but what can you get really quick now? You can get the 3rd side, and what are you allowed to use now that I didn't want you to use before? The Pythagorean Theorem. Why can you use it now, but I didn't want you to use it before? Yeah, everything that's given, everything you're going to plug into the Pythagorean Theorem, it's all given. So we guarantee it's correct. So fill in a squared plus b squared equals c squared. So we get 3 squared plus 2 squared equals c squared. 3 squared is 9, 2 squared is 4. 9 and 4 gives me how much? 13. And my last step to get rid of squaring is to square root both sides. Okay, you could leave it as an exact answer. I think the book is going to round it most of the time in this section. So let's do it the way they're going to do it. 3.606. Now, are we going to use C to do anything else in this problem? No, forget about it. It's done. You're never going to use it again. You're going to use A and B for everything. Let's make a diagram. I'll put A across from alpha, B across from beta. And in fact, I'm not even going to label what C is in my diagram because I don't want to get mixed up and accidentally use it. Just leave it as C. Okay, now we can find alpha or beta. Okay, it doesn't matter. Let's do alpha. And what are the other two things that I'm going to use? Yeah, the 3 and the 2. Okay, so take a look at that for a second. See if you can figure out what trig function you need. Tangent. Okay, everyone see why it's tangent? 3 is opposite, 2 is adjacent. I'm not doing anything with hypotenuse in this problem. That's done. Hypotenuse is done. So I get tangent. What do I plug into tangent? What's going to go right here? Tangent of alpha. Good. Equals opposite over adjacent. What's different about this equation compared to the ones we just did in the previous problem? You're given, yeah, so the trig function is equal to, we know both numbers. Okay? It's where the variable is. Okay? We did one where the variable was in the top of the fraction, the bottom of the fraction. Now it's in the trig function. So our goal is to get alpha by itself. Any guess on how we can get alpha by itself? All right, so a lot of people guess that. They say, why don't you divide by tangent? Well, tangent's a function. So we can't divide by a function.
You can't do like the opposite function.
You can do the opposite function. If you can think of what undoes tangent. The inverse of tangent, right. And if people get stuck on this, what I usually show them is something like this. I say, well, you can't divide each side by 2 to solve that. Squaring is a function. So you need another function that will undo it. Square root. Square and square root. Right? Same idea here. Tangent is a function. So what we're going to do is we're going to take the inverse tangent of everything on the left and the inverse tangent of everything on the right. Okay. Look at that left-hand side. Inverse tangent of tangent and then an angle. Does that look familiar at all?
Yeah.
We did that yesterday. We did that right here. Inverse tangent of tangent. We basically said these things cancel out. And the answer is going to be by itself on the left-hand side. So we get alpha equals inverse tangent of 3/2. Just type that in and make sure you're still in degrees. Second inverse tangent, 3/2. Okay, so now we got 56.31. Just round it to 3.1. Now you could subtract that from 90 if you were running out of time to get beta. The only danger with doing that is if you got alpha wrong, well, you just got beta wrong. So let's find beta. We'll finish up finding beta the same way. Find beta. Use the 2. And use the 3 again. Which trig function this time? It's tangent again. But it's not quite the same thing. What happened? Yeah, the 2 and the 3 switched places in terms of opposite and adjacent. Now, 2 is opposite, and 3 is adjacent. Right, so tangent of beta equals opposite over adjacent, 2/3. I'm going to do the same thing I did last time. Take the inverse tangent of each side. And that's my answer. Okay, so we can guess, I mean, it should come out 90 minus 56.31. You could check what that is. Check what this is. And if they come out the same, you're guaranteed you did it right. Okay. Inverse tangent of 2/3. 33.69, and if you add these two up, they do add up to 90. So you did it right. Okay, any question on that one? Okay, so anytime that you're given 2 sides to start with, you're going to have to use inverse trig. If you don't know an angle, that's what inverse trig is for, to find an angle. This is the same type of problem again. Let's finish up with this one. Okay, this one says you're just taking a 20-foot ladder, you're going to lean it against a house. The angle between the house and the ladder is 17 degrees. I want to know how high the ladder will reach. Okay, what do you think this kind of problem, it lends itself to a certain way of solving it. What do you think would be helpful to do here? Yeah, just sketch it out. Okay, draw the ground. Okay, draw your building. And there's a ladder leaning up against it. Maybe something like that. So by drawing the building and the ladder, what kind of shape did we really just make? We make the right triangles, right? Specifically, the building, we're going to assume it's perpendicular to the ground. Okay. That's not always the case. In fact, in the next unit, we'll look at a problem with the Leaning Tower of Pisa, where it's not perpendicular to the ground. And that changes things. But that's a couple weeks away. Okay, but this is perpendicular to the ground. Where's this 20 going to go? What is that?
The ladder.
It's the ladder, and in terms of triangles, what is it? Yeah, it's my hypotenuse. What about the 17? Where does that fit in?
The ladder.
Yeah, Grant?
Alpha.
So where would you put it? Up here?
One of the, no. Yeah, one of those where the right triangle is.
Okay, it does make a difference which one, because they specifically say it's the angle between the ladder and the house. So where would it have to go? It has to go at the top. If you put it at the bottom, it comes out wrong. Okay, and they want to know how high the ladder will reach. So what are you basically trying to find in that triangle? The height. That's all you want to know. What's the height of the triangle? Call it A, X, whatever you want to call it. Okay, same idea as what you did before. Solving for that, you're going to use the 2 pieces of information that were given. Anybody see which trig function I'm going to use? Look at what you know. Look at what you want to know. Figure out the names of those sides.
Adjacent over hypotenuse.
Yeah, what is that? That's correct. Cosine. Good. So the cosine of my angle equals, as Emily just said, adjacent over hypotenuse. Oh, 17, thank you. That would mess things up a little bit too. So cosine of my angle equals adjacent over hypotenuse. And last step to get A by itself. Multiply by 20. Multiply by 20. So we're going to type 20 cosine 17, see what we get. What do we know though? The ladder is 20 feet long. My answer has to be what? It's got to be smaller than 20. Okay, the ladder is at an angle. It can't reach higher than 20. So let's see what we got. The ladder will reach about 19.13 feet. Okay, and that's how high up the ladder will reach. All right, so tomorrow we'll go over this. Okay, any of the questions on the homework? Then we'll have a test on just 2 sections, just 3-1 and 4-1. As I said, there won't be any assignment over shop week. Okay, but this one will be due tomorrow. Okay, so page 255. Okay. 13 and 15, that's what you did yesterday. You did 9 and 11, so I'm just having you try 2 more of those. 13, 15, 20. And then the rest is odds. 31 to 39 odd, 43 and 47. 51 to 55 odd. And I will be after school for extra help today.